Hello everyone, welcome to my video on scientific notation. We're going to be adding, subtracting, multiplying, and dividing now. If you haven't seen the conversion video, go back and watch my video on scientific notation, because in order to add, subtract, multiply, and divide, you have to know how to convert. Okay, so go watch my previous video if you haven't done so already. But how do we add and subtract? Let's start off with addition, subtraction. We're given this example here, 2.3 times 10 to the 3 plus 4.5 times 10 to the 2. How do we add or subtract these guys? The idea is to convert. We convert this, which is in scientific notation, to a number, do the addition or the subtraction depending on the problem, and then convert your answer back into scientific notation. Okay, so that's the game plan. Let's go ahead and do this together. So the next step, we have 2.3 times 10 to the 3. The first bracket, how do we do that? So you have to remember from the previous video, since our exponent is positive 3, we have to move the decimal 3 times to the right. Okay, this is how we learned it. So if we move the decimal 3 times to the right to 3, and we fill in the blanks, the empty spaces with zeros, the first number is really just 2,300. Okay, so 2.3 times 10 to the 3 is really just 2,300. Plus, let's look at this number here. We have 4.5 times 10 to the 2. This is, since the exponent here is positive 2, we move to the right twice. So 4.5 times 10 to the 2 is really just 450. Okay, and now we can add these two numbers. This is easy to do. We know how to do this, so we get 2,750. So the answer we have right here is non-scientific notation. It's a number. So your job is to convert it back to scientific notation. Let's go ahead and do that. So recall that the decimal is always at the end of the value, at the end of the number. And in order to transform this into scientific notation, we want to ensure that the decimal is placed right here, 2.7, because this would force our number to be in between 1 and 9.99 repeating. So what do we have to do? In order to move our decimal from the blue one to the red dot, we're moving to the left 1, 2, 3 times. Okay, so if you remember the rules, this means that our value is equal to 2.75. If you want to add the 0, you don't have to. I'll leave it as 2.75 times 10 to the, since we move to the left, this turns our exponent positive. Okay, so the answer we get is 2.75 times 10 to the 3. Let's look at another example. Okay, so in this example here, we have 6.4 times 10 to the 3 minus 9.2 times 10 to the 2. So in this case here, we're subtracting, but it's the same game plan as we had with the addition. So what we have to do is begin by converting our numbers in scientific notation to a number, perform the operation, and then convert our answer back to scientific notation. So let's begin with the 6.4 times 10 to the 3. In this case here, the exponent is positive 3, so we have to move the decimal 3 times to the right. So let's go ahead and count 1, 2, 3. Put our decimal place here and fill the empty spots with zeros. So we get 6,400 minus, let's look at this bracket on the right. So we have 9.2 times 10 to the positive 2. So since the exponent is positive, we move the decimal to the right 2 times and fill in the gaps with zeros. So this gives us 920. So now we do 6,400 minus 920, and that gives us 5,480. The next step is to convert back to scientific notation. So remember that every number, the decimal is at the end. We want the decimal to be placed between the 5 and the 4 for it to be in scientific notation. That means we have to move the decimal 1, 2, 3 times to the left. Okay, so if you remember our rules, when we convert from a number to scientific notation, since we're moving 3 times to the left, this means that the exponent is going to be positive. So we get 5.48 times 10 to the exponent 3. And this is our answer in scientific notation. Okay, so let's continue with a couple more examples here. I urge you to pause the video, try to work these problems out on by yourself, and then see if you get the same answer as me. So let's look at example 3a. What we have is 5.3 times 10 to the positive 4 plus 7.5 times 10 to the 3. So let's begin by converting this to numbers. 5.3 times 10 to the 4. We move the decimal 4 times to the right. 1, 2, 3, 4. And we fill in the gaps with zeros. So this gives us 53,000 plus 7.5 times 10 to the 3. We move to the right 3 times. Fill in the gaps with zeros, and we get 7,500. Okay. Now we add the two numbers, and this gives us 60,500. And now we have to convert this back to scientific notation. So remember, the decimal is always at the end of the number. In this case here, where do we want to put the decimal place? If you're going between the 0 and the 5, that's wrong. Make sure the number you're choosing is between 1 and 9.99 repeating. So we want between 6 and 0, because 6.0 or 6.05 falls in between 1 and 9.99 repeating. This means that we have to move the decimal to the left how many times? 1, 2, 3, 4 times. Okay, since we're converting from a number to decimal to scientific notation, we have to, and we're moving to the left. That means our exponent's gonna be positive. Okay, so this is our answer: 6.05 times 10 to the 4. If you added 2 zeros after the 5, that's correct as well. Okay. Good. Now let's move on to B. In this example here, we have 7.94 times 10 to the 2 minus 9.15 times 10 to the 3. Same game plan. Let's convert this to numbers. So 7.94 to the exponent 2 is 794 minus 9.15 times 10 to the 3. We move the decimal 3 times. So we get 9,150. 794 minus 9,150. Use a calculator. 9150. We get negative 8,356. Okay. The fact that the number is negative shouldn't bother us. That's okay. So the decimal is still after the 6. It's at the end. We want the decimal to be between the 8 and the 3. That means we have to move our decimal 3 times to the left. 2, 3. Since we're moving to the left 3 times, this means that our answer in scientific notation is 9.356 times 10 to the positive 3. Okay, and that's the final answer. Keep up the great work, guys. Keep practicing, and I'll see you in the next clip. So we saw how to add and subtract scientific notation. Now let's take a look at how to multiply and divide in scientific notation. Here the strategy is different, and in order to do so, we have to apply some properties that we learn in laws of exponents. Okay, so if you haven't seen this, it's fine. I'll talk more in depth about these properties, but for now I just want you to know them. The first property that we need is if we have xm times xn. Whenever you're multiplying two numbers and the bases are the same, what do? You have to add the exponents. So x to the m times x to the n is really just x to the m plus n. You add the exponents m and n. Okay, that's the first property. So whenever you're multiplying the same base, you add exponents. Property number 2 is for division. Whenever you're dividing two numbers that have the same base, you, in this case, subtract the exponents. Okay, that's the game plan. So ideally what I'm saying here, just a quick example. For the first one, if you have, let's do x to the 2 times x to the 3, what is that equal to? Well, if you have x squared here times x cubed here, since they're both x's, they're the same, you just add the exponents. So 2 plus 3 is 5. So the answer is just x to the 5. Okay. And similarly, if we have x to the 4 over x to the 3, since the bases are the same, they're both x's, what do you do to the exponent? Since we're dividing, we subtract the exponents. So it's x to the 4 minus 3. And when you're subtracting, it's always the top exponent minus the bottom exponent. Okay. So the exponent in the numerator minus the exponent in the denominator. And that gives us x to the 4 minus 3, which is x to the 1. Okay. So keep this in mind, we have to use both these properties. when multiplying and dividing in scientific notation. Okay. So let's take a look at an example together. So the example I have is 3.4 times 10 to the 3. Let's put this in bracket. Times, I'll put a little dot for multiplication. 4.2 times 10 to the 2. So the game plan here when you're multiplying, this we'll start off with an example of multiplication, then I'll show you division. For multiplying, what you do here is you don't have to convert to a number. You start off by just multiplying the two numbers first. Okay, so the numbers in the front, you have 3.4 in this case, and here you have 4.2. Multiply them. What's 3.4 times 4.2? Times 4.2. Let me just quickly write the answer and put arrows. .4 times 4.2, let me use a calculator, we get 14.28 when you multiply these two numbers. Times 10 to the, now you're multiplying 10 to the 3 with 10 to the 2. And this is where we use the first property. Since we're multiplying, what do we do to the exponents? Notice that the base is 10 here and the base is 10 here. The bases are the same. So all you have to do is add the exponents. So in this case here, the exponent is 3 plus 2. The exponent here is 3 and the exponent here is 2. You just add them. So you get 14.28 times 10 to the 3 plus 2 is 5. Okay. Great. But if you stop here, that's wrong. So be very careful. Is this scientific notation? No. Don't fall for this. Most students will stop here and you wouldn't get full marks. 14.28, this number here in the front is bigger than 10. So this is not in scientific notation. So you have to convert this to a number and then back into scientific notation. Teachers give tricks where you have to add the exponent. That's not necessarily true, it depends on the number. So the best thing to do here is to convert it to a number and then come back to scientific notation. Okay, so let's go ahead and write this as a number. The exponent is 5. Since we're converting from scientific notation to a number, we have a positive exponent. It's 5, so we have to move the decimal 5 times to the right. 1, 2, 3, 4, 5. So the value here is 1,428,000. Okay. And now we go back to scientific notation. So the decimal's at the end. Now we're converting to scientific notation. We want the decimal, let's do it in red, to be between the 1 and the 4, not the 4 and the 2, the way it was here. Okay, that means we have to move 1, 2, 3, 4, 5, 6 times to the left. So our answer is really 1.428 times 10 to the positive 6 because we moved to the left. And this is the correct solution. So now in this example here, example 2, we have 5.4 times 10 to the 8 divided by 7.2 times 10 to the 5. Now we're dealing with division, but we do the same idea as we saw before. We just divide the first numbers over here. We divide 5.4 with 7.2. So when you divide those two numbers, 5.4 divided by 7.2, we get 0.75. Let me just put an arrow to show that this 0.75 was the division of these two numbers. Okay. And then times 10 to the, what do we do to the exponent? Recall, we're dividing. The rule is when you divide the same base, in this case the base is 10, they're the same, you subtract the exponents. So all we have to do now, instead of adding, because before it was multiplication, we added, now that we're dividing, we have to subtract these two exponents. So we get 8 minus 5. So this gives us 0.75 times 10 to the 3. Okay. And this is our answer. The issue with this answer, again, this is not scientific notation. Okay, this is what you guys have to catch and be careful. Students tend to stop here. That's wrong. this number 0.75 is smaller than 1. The number here has to be between 1 and 9.99, repeating. Okay, so we have to convert this to a number and convert back. Recall in the previous example that our exponent went up by 1. Let's see what happens now. Because just adding 1 to the exponent isn't a good trick. So let's convert this to a number. The exponent is 3, so that means we have to move the exponent 3 times to the right, 2, 3, plug in a 0, so this gives us 750. Okay, now let's go back. Our decimal is here. Where do we want it to be? We want it to be between the 7 and the 5, 7.5, and that means we have to move to the left 2 times. Which means that in scientific notation, the proper scientific notation, it gives us 7.5. You could add the 0 if you want, times 10 to the positive 2. So in this case here, in this example, we actually had to subtract by 1. Okay, so be careful with that. I strongly encourage you guys to go from scientific notation, convert it to a number, and convert it back. Okay, so let's take a look at a couple more examples, and we'll keep practicing. So let's continue with these examples here. Example 4. Once again, I strongly encourage you guys to pause the video, try solving these on your own, and compare your answer with the answers that I get. So looking at example 4a, we have 8.14 times 10 to the 4 multiplied by 3.2 times 10 to the 3. So let's go ahead and convert this. No, not convert it. Let's multiply the numbers in the front. So 8.14 times 3.2. 8.14 times 3.2. We get 26.048. 26.048 times 10 to the. So here we're multiplying. We have to add the exponents. 4 plus 3. We get 10 to the 7. Okay. So once again, we can't stop here. We have to. This value here is non-scientific notation. So let's convert this to a number. This means that we have to move the decimal to the right 7 times. So we get 1, 2, 3, 4, 5, 6, 7. Make sure you don't make mistakes counting. So we get this very big number, 26.048, 0.000, 4 zeros at the end. And now we have to convert this back to scientific notation. So our decimal place is here. We want it to be between the 2 and the 6, not the 6 and the 0. So that means we have to move it 1, 2, 3, 4, 5, 6, 7, 8 times to the left. So the solution is 2.6048. Again, you could add the zeros if you want. I'm not going to do it. Times 10 to the positive 8 because we moved to the left. And that's the solution for part A. Okay. Let's look at part B now. This is a division problem. So we have 6.9 times 10 to the negative 4 divided by 2.4 times 10 to the negative 7. So we begin by dividing our first two numbers here. 6.9 divided by 2.4. Let's do that on the calculator. Okay. And we get 2.875. 2.875 times 10 to the. Here we're dividing, so what do we have to do? We have to subtract the answer. So negative 4 minus negative 7. So just be careful with your negatives. Negative 4 minus negative 7. Two negatives here turn into positive, so it's really negative 4 plus 7. This means that we have 2.875 times 10 to the positive 3. Okay. Do we stop here? Now we could, because 2.875 is in scientific notation. This number is between 1 and 9.99 repeating, so this is correct. Okay. Great work, guys. Okay, so let's test our knowledge. Let's combine everything we did in the previous video, the previous examples, and try to answer this question here. So what we have to do is convert this into scientific notation. So we have 5.8 times 10 to the 6 times 8.2 times 10 to the 2. All that divided by 2 times 10 to the 12. Okay, so you might have questions like this where it looks like we've never seen a problem like this, but just break it down into steps. So if you kind of ignore the denominator for now and focus just on the numerator, we know how to multiply those guys. We did this in previous examples. So let's just start off by multiplying the top. Okay, so 5.8 times 8.2. Let's multiply those two numbers. Let me underline them. Okay. 5.8 times 8.2, we get 47.56 times 10 to the, here we have exponent 6, here we have 10 to the exponent 2. Since we're multiplying, we have to add the exponent, so 6 plus 2, so we get 8. All this divided by 2 times 10 to the 12th. Okay. So our answer is not in scientific notation. We got 47.56, but it's okay because we're not finished. So what we could do is go ahead and divide. So the way it's written here, you could think of this. This is equivalent to 47.56 times 10 to the 8 divided by 2 times 10 to the 12. These are equivalent. They're just written differently. Both mean the exact same thing. Okay, so if you like this notation, what we've seen in previous examples, then you can think of this or rewrite this as this. And now we divide. So we have to divide this with the 2. So 47.56 divided by 2, we get 23.78 times 10 to the, so here we have 10 to the 8, and we're dividing times 10 to the 12th. This means that we have to subtract the exponents, 8 minus 12. And when you do 8 minus 12, you get negative 4. Okay. So again, stopping here is not correct. This is not in scientific notation. We have to switch it to a number and convert back to proper scientific notation. So writing this as a number, now our exponent is negative, which means we have to move the decimal to the left 4 times. So we get 1, 2, 3, 4, put our decimal. So we get 0, these are filled with zeros. So we get 0.002378 as a number. And now we have to convert back to scientific notation. Where do we want the decimal to be? We don't want it between the 3 and the 7, we want it between the 2 and the 3. Which means we have to move how many times? 1, 2, 3 times to the right. Now we move to the right, so we get 2.378 times 10 to the, since we went to the right, it's negative 3. And this is our answer. Okay, so let's continue with this example that we have over here. So what we have is 6.5 times 10 to the 50 times 3.7 times 10 to the 130. All that divided by 1.25 times 10 to the 25 times 4.81 times 10 to the 75. Don't let the large number intimidate you. Do the same thing as we did in the last video. Pause the video, try it yourself, and see if you're able to get the same answer as me. Okay. So what I would do here to start off is I would start off by multiplying the numerator and then multiplying the denominator. So let's start off with the numerator. So on top we have 6.5 times 3.7. Let's multiply these guys together. I'm not dealing with the division yet, I'm just doing the multiplication. So 6.5 times 3.7, we get 24.05 times 10 to the, since we're multiplying and we have the same base, we have to add the exponent. So 50 plus 130, what we get is 180. Okay. All that divided by, and now let's multiply the numbers on the denominator. So we have 1.25 times 4.81, so let's go ahead and do that. 1.25 times 4.81, and we get 6.0125. 6.0125 times 10 to the, here it's 10 to the 25, here it's times 10 to the 75, so 25 plus 75, we get 100. Okay. So we finished the multiplications. Again, the number on top is not in scientific notation, but it's okay because we're not finished. Let's do the last step here. The last step is to divide. So we begin by dividing the numbers in the front. 24.05 divided by 6.0125. Let's divide those guys. And we get 4 times 10 to the, and since we're dividing, we have to subtract the exponent. So on top we have 180, on the bottom we have 100. 180 minus 100, we get 80. And this is our final answer, 4 times 10 to the 80. 4 is between 1 and 9.99 repeating, so that's our final answer. Great stuff, and I'll see you guys in the next video. Keep it up.